Okay, it says we're starting now. This is on video now. We're going to have a test a week from today, you've all been told, and it's been recorded on video. Okay? We're going to do 16. So chapter 16 is constructing a confidence interval for a mean, and an important thing is the standard deviation is known. Okay? We are going to learn how to do this when the standard deviation is not known in the future, but today we're going to pretend that we always know what it is. Okay? So let's talk a little bit about the requirements. Okay? Number one, the data must come from an SRS. What is an SRS? Simple random sample, okay? Must be a random sample. Number two, it comes from a normal population, and your n has to be greater than or equal to 30. Number three, sigma is known, okay? If sigma is unknown, we're going to do it's very similar, but slightly different process. Okay, so we'll learn that on another day. Okay, the book hints it's in chapter 19, but it's not really. Okay, actually, what they do in chapter 19 is wrong, and I'm just going to teach you the right way. Okay, all right. So let's talk a little bit about what we call a point estimate. Okay? It is the value of the statistic that estimates the parameter. Okay? So can you guys give me an example, and if you want to look back at Tuesday's lecture, an example of a point estimate? I think I gave you 3 examples. I know it's in Tuesday's lecture. I want you to give me an example of a point estimate, which is a statistic. You can guess. Would you say 41%? 48%, but that's like a specific example. I want a generic example. Yes, 48% is. What letter do I use? That's what I'm really asking.
Oh, S.
Would you say?
S.
S? S would be one example. It's not one we're going to worry about in this class, but if you decide you love statistics, come take my 2040 class. We'll learn more about S. But there's 2 others.
X bar.
X bar, very good.
You got this.
Okay, and the final one?
P
hat. Okay, we're going to concentrate mostly on those 2, and in fact, we're going to focus only on X bar today. Okay?
What does S mean again?
S stands for? Not statistic. It is a sample something. Sample standard deviation. Okay, so we are going to use S. We're not going to do a confidence interval on it though. That's for 2040. Okay. All right. So let me do most. I'm going to abbreviate CI for confidence intervals. Take the form of the point estimate plus or minus your margin of error. Okay? So, all right. Let's talk a little bit about the margin of error. Okay? It is a measure of how accurate the point estimate is. Okay? Now, let me ask you a question. Who was supposed to win the 2016 presidential election? Hillary was supposed to win, right? Did you know that they were wrong, right? Did you know that there's a website called 538.com and they predicted all 50 states plus the District of Columbia, so 51 polls. They got 47 of them right. The problem was they got 4 states wrong. But those 4 states swung it from Hillary winning to Donald Trump winning. Okay? And in fact, who won the popular vote? Hillary won the popular vote, so they were correct. Problem is, this stupid electoral college, those 4 states swung the whole election. But they actually got the popular vote right. Hillary won. Okay? So the idea here is you would expect, well, actually, let me back up. Somebody had a question. Dale, did you have a question?
No,
okay. So the idea here is we're going to have some sort of a, with your margin of error, you're going to have a level of confidence. Okay? This gets a little bit light. I'm going to pick a different color because it's kind of dark. Okay? You're also going to have, I don't know if red's any better, we're going to find out. You're also going to have a sample size. And you're going to have the standard deviation of the population. Now, that's not true in Hillary's case. We didn't know what that was. But we're going to assume that we know what it is today. Okay? All right. So, let's see here. Okay, so let me back up. Let me share a spreadsheet here. If you've pulled up my the formula sheet that I popped up there, I'm going to pull this up again here. Where is it? Right here. Let me share this on the video.
your screen's not on.
Oh, it's not on. Thank you. I forgot to turn it on. Okay. Share. All right. So over here, as soon as the camera warms up, you can see here that we've got the graph here of the normal probability. The left side is shaded. The thing is taking a long time to warm up. Below that, we have this confidence interval table. Okay? This is coming into focus now. Okay? The most common forms of confidence levels are 90, 95, 98, and 99. Sometimes you'll go back to 80, but think of it this way. You guys all remember the 68, 95, 99 rule, right? Let me stop sharing for a second. We're going to go back to the board. Okay? Okay, what's the 68, 95, 99 rule say? Yes, if I go out 1 standard deviation, negative 1 to 1, you get 68%. 95% within -2 to +2. So you could kind of think of that as you could think of this as a 68% confidence interval. You could think of this as a 95% confidence interval. And if you went from -3 to +3, that's a 99.7% confidence interval. Okay? All right. So this works the same way. What we're going to do, the problem is, okay, if this is your population, you remember when we did the IQ scores the last time? Okay? That's actually a fun little thing. We're going to do that again, okay? going to show you that, but I want to make sure that we can do a confidence interval. But the idea here is you're going to come up with a sample population. It may be above the mean, it may be below the mean, okay? The idea here is you're going to go out, typically the most common is 95%. And then you're going to say, we are 95% confident that, and I'm going to put the word true mean, but you should enter in whatever you're measuring, the age of freshmen at UVU, or the price of eggs at Smith's Market, or whatever. Whatever you're measuring is between, you can put the lower and then the upper value. Okay? So this is what's known as a confidence statement. And I probably should have put, I'm going to put that in parentheses, because typically 95 is the most often used, but you could be 90%, and I'll even show you how to be 80% confident. We'll talk about that in a minute, okay? All right, that's off the board there, okay? So there you have it. So that's what we would call a confidence statement. So the formula that you're going to use for this section is going to be x bar plus or minus z sub alpha over 2. I think they just use z in the book. I like to use it this way. Times sigma divided by the square root of n. Okay? That's the formula that you will see on your formula sheet that I posted in the announcement a long time ago.
Is that sub alpha over z?
Sub alpha over 2. Okay? So let me explain what's happening here. So the idea here is you do some sort of a sample. You talk to 100 people, 500 people, 1,000 people, whatever you do. Okay? 30 people, whatever. And you're going to get some sort of an X bar, right? You don't know if your X bar matches the real mean, okay? It could be higher, it could be lower, right? So the idea here is, so one way to think about it is if you go out 2 standard deviations, right? Okay? You could be 95% confident that the true mean might be here, mean might be here. It also could be out here, right? Because you could be wrong. But if you repeat this experiment 100 times, 95% of the time, your confidence interval should contain the true mean. 5% of the time, you're going to be wrong. Okay? On average. And so that's what you can think of as a confidence interval. Now, typically, you don't do a poll 100 times, you do it once, right? And so you typically say, well, we're 95% confidence that we did a good job. We're 5% confident that we did a bad job. Okay? Does that make sense? All right, so let's do a quick example here, and then I want to show you, we'll go back to that example we did on Tuesday, and then we're going to see how it works in action, okay? So, city owners were concerned about speeding on a freeway. Okay. They did a simple random sample of 12 cars, which isn't very many, is it? It's kind of a small sample size, and found a mean speed of 59.62. The speed limit was 55 miles per hour. Okay, so what I want you to do is find let's start with a 90% confidence interval for the true speed. We're going to compare that with 95% confidence interval, and we're going to compare it with a 99% confidence interval. Okay? And then finally, question D, is there evidence to support speeding?
Is this a question on the homework?
No, but it's very similar to the question on the homework.
Yes.
Have you started doing it and it looks familiar?
No, I was just wondering.
Yeah, it's very, very, very similar. Okay? All right, so we're going to use this equation here. And Robert, can you help me punch stuff into this equation?
Yeah, so X bar is going to be 59.62.
59.62.
And then
Oh, you know what? I forgot some information I need to tell you. The police tell you standard deviation is 8 miles per hour.
so he's going to be 8,
Okay. Sigma's going to be 8,
and it's going to be 12.
N's going to be 12.
And
And then we got to figure out what z sub alpha over 2 is. Okay?
What's that thing called? The
Alpha.
2?
Yeah, so let me, actually, that's a good question. Let me explain what that is. So the idea here is, as I've shown you a bunch of times, okay, we have our X bar here, right? So in this first case, in part A, I want 90% to be within these two areas here, right? Okay, so we refer to alpha equals our significance level. Okay, how much are in the tails?
5 each.
We got 5%, okay? So in this case, if I'm 90% confident, what's my lack of confidence?
10.
I've got 10%. So my significance level is 10%, which means how much do I have in this tail? I've got 5% in this tail, and I've got 5% in this tail. So this is what I refer to as my alpha over 2. This is also my alpha over 2. Add them together and you get your alpha, okay? So that's what that means. Okay, so I've got z sub alpha over 2. Now, let me go back to my table for a minute here. Okay. Oh, did I close it? There it is. Okay. Now I've got my table right here. These are my most common things here. So if I've got 90% confidence, what's my critical value?
1.64.
Nobody's forced to sit in the back.
I wouldn't be able to read it from here.
1.645, right? Okay. So in this case, my z sub alpha is 1.645 because I'm going for 90% confidence. Okay. All right. So Robert's identified everything. Gentry, can you plug all of these numbers into this equation right here? Okay. Let's stop sharing. We're going to come back to the board. Okay.
9.62.
59.62 plus or minus 1.645 standard deviations away times
8 divided by
square root of 12. Okay, so basically what you're going to have to do is you're going to have to do this twice. I'm going to show you how to do this on the computer, but you'll have to do it on your calculator just as well. So if I go back to, let's open up a new spreadsheet. Question, go ahead.
What if it's not like a pretty 90% CI?
We'll talk about that in a minute. Okay, but those ones there, I'm gonna tell you about. In fact, we'll do an 80% just for fun. Okay, so if you're doing this on here, upper, excuse me, let's go lower and upper. Okay, so this is going to be 59.62 minus 1.645 times standard deviation is 8 divided by the square root of 12. Okay? So my lower limit is 55.8. I'm going to copy, I'm going to paste this, but I'm going to change that minus now to a plus. Okay? So, JC, can you follow this little template here and tell me the confidence statement?
We are 90% confident that
Speeding
That the speed of motorists is,
between
maybe I should say the mean speed. Mean speed of motorists is between 82, we'll stop there, and 63.42. So let me ask you a question. If the speed limit is 55, can you say confidently that people are speeding?
Yeah.
Yeah, because 55 is lower, right? So yes, people are speeding. Okay, so at a 90% level, we could say yes. Now, what's the probability you're wrong? 10% chance you're wrong. Okay?
Would it be 5 though?
What would
Would it
be
be
5?
5 that it's under the speed limit, and then other 5 that's even more?
Yeah, 5 on each end. Yeah,
So that'd be 5% below the speed limit.
Well, we're 90% confident that the true mean is between 55.8 and 63. Okay, so that's for 95% confidence. Let's do it again, this time for 95% confidence. Okay? Now I need to look up my z sub alpha over 2. So everything's the same that I wrote on the board, except for what's going to be my z sub alpha over 2 this time for 95% confidence. Let's look at our chart here.
How do you figure that out without looking at the chart?
You don't.
Oh, you can.
You can't figure it out without looking at the chart. Okay? All right, so 95% confidence, what's my critical value?
1.96.
1.96, which is very close to 2. Remember? Do you remember the 68, 95, 99 rule? We said 2 standard deviations. It's actually 1.96. We rounded. Okay, so it's 1 point. So yeah, so that makes sense because that totally follows the 68, 95, 99 rule, right? Okay, so this time, let me show you this. We're going to copy this whole thing here. I don't need that. And we're going to do the upper and the lower, okay? But this time I'm going to change the 1.645 to 1.96, okay? And I'm going to change this to 1.96, okay? What do you notice about your, so actually, let's do this. So Zoe, can you help me modify this statement?
So it would just be, we are 95%.
95% confident
And then
that the mean speed of motorists is between
55.09.
55.09 and 64.15. Okay? Can we still say that people are speeding?
Yes.
Okay, but we've got the Dukes of Hazzard Sheriff now, right? You're 0.09 over the speed limit. Would you get a ticket for 0.09 over? Probably not. That seems a little bit, but yeah, technically, you know, if you're going to go 55.0, you're 50.09, you're speeding, right?
Doesn't go into the decimals.
Okay. All right, let's do this again, this time for 99% confidence. I'm going to do it over here. Okay. So now, what's my critical value? I got to look at this page here. What's my critical value for 99% confidence, Brock? 2.575. Okay, it's that number right there. So now we're going to change this to 2.575 on the low side and 2.575 on the high side. Eddie, what's my confidence statement?
We are 99% confident.
So we're way more confident, right? That the mean speed is
55.09. 63.67
67, and
65.56.
65 point what?
56.
56. Okay, 57, we'll round it. Okay? Can you say with 99% confidence that the people are speeding?
No.
No. So the more confident you get, what happens to your margin of error? Yeah. Now, just let me show you this really quickly. One of the ways you can think about this is, okay, this part of the formula right here, this is your point estimate, right? This is your margin of error, okay? So when your confidence level gets bigger, in fact, let me show you this really quick. Let me share again, okay? We're going to compare the 95 and the 99 here. And then I'll let you go, okay? So if I take this formula here, all I need to worry about is this, the z times sigma over the square root of n. So my margin of error for 99% is, if I put an equal sign in there, almost 6 miles per hour, right? If I go here, the margin of error is equals less than 4. So as I get more confident, what happens to my margin of error? It gets larger. As I'm less confident, my margin of error gets slower, okay? All right, I didn't have time to do that. Maybe I'll save that for the review on Tuesday, okay? So the quiz on Tuesday is going to be on chapter 16, 15. What is this chapter? 16. Yeah, chapter 16. We'll have a review on Tuesday. We'll do our test on Thursday. Oh, I forgot to schedule the test. I'm going to do that right now. But I'll tell you on Tuesday for sure, unless you want to stick around and I'll tell you.
Did you grab the test?
Did I what?
Did you group the
No, I
test?
didn't. I was doing the answer key.
Thank you.